Today we're going to learn how to find the domain from an equation. This is really coming from section 2's homework. However, the problems in the homework for 2.2, the problems that are in that homework are harder than what you're going to see on the test. So this is why I'm going to give you a bunch of examples that I'm going to do in the video. Now, I'm probably not going to get through all of them with you, but I will make a video of all of them, and then tomorrow I'm going to practice this some more with you. Now, when we covered these basic functions in section 2.5, does anybody remember what the domain of a quadratic function is?
All real numbers.
All real numbers. Remember that u gets bigger and wider. So this one, you're always going to start out by thinking the domain is always all real numbers. There's only going to be 3 scenarios when we're going to exclude numbers. One of the scenarios is when it's a fraction, because what wouldn't work in a fraction? So like, let's say I have 1 over x. Anything that makes the denominator a 0. The other thing we're going to check for are square roots. We don't want any imaginary numbers, so all of our square roots have to be positive numbers. Other than that, your domain is always all real numbers. So this domain, and we're writing it in interval notation, is all real numbers. You need to remember that the graph of the quadratic function, whenever you see an x squared, is always going to be all real numbers. Back. So my second example here, anybody remember me telling you the domain for the x cubed graph? All real numbers again. Remember, this looks like this, and eventually it's going to cover the whole x-axis. So domain for the cube function is all real numbers. All right, so here's our first exception. What would make this function not work?
0.
Exactly. So when you have a fraction, you take the denominator and you're going to set it not equal to 0, because this is what x can't be. And written in interval notation, we're going to exclude the 0. So if this were on a number line, it would have a hole here at 0, but then it would go from negative infinity to positive infinity. So everything, but it jumps over the 0. The way that we would write this is negative infinity up to the 0, jump over the 0, so we'll union that. Then when we get on the other side, we start again and go to infinity. Another fraction. Again, we're going to set that denominator not equal to 0. And I can solve this 2 ways. I can either factor it, or I can use the square root method. I don't care which method you use. We just have to solve. X plus 2 not equal to 0. X minus 2 not equal to 0. So x cannot be negative 2, and x can't be positive 2. If you use the square root method, you would add 4 to both sides, and then square root, and plus and minus 2. Either way. So again, we're going to write the domain in interval notation. It's got a hole here at negative 2, a hole at positive 2, and then otherwise it's every other part of the number line. So again, where these holes are, that's where my u's are going to be. So it's going to go from negative infinity. It's going to put on the brakes at negative 2. Jump over the negative 2, start up again on this side, jump over it, start up again, and then go to infinity. Another fraction. Okay, now we're only testing for numbers to exclude that are real. Watch what happens when I do this one. When I move the 1 over, I get square root x is equal to plus and minus I. I don't care about excluding i's, so my domain here is all real numbers. So if you get an imaginary solution, we don't care about excluding it. It's going to be all real numbers. Next one is a radical. For radicals, we don't want negative numbers. So when we have a square root, we take what's underneath it and make it greater than or equal to 0, because I don't want a negative number. And again, in interval notation, this would look like a bracket pointing this way. So from 0 with a bracket to infinity.